This is the quiz that you just took here. All right. Number 1, what mass of water at 100 can be turned to steam at 100 when 24,000 kilojoules of heat are added? Where are we on the heating curve for water, Corbin? Are we at 0 or 100 here? We're at 100. All right. We're at this zone right here. We're going to use the heat of vaporization. What is the actual exact temperature change when we're at 100 going to 100? It's nothing, right? Temperature change is 0. All right, so what would happen if we used Q equals MC delta T here? It wouldn't work. It would give us a 0, and we know that there is heat required for vaporization to occur. So we're going to use this formula right here. All right, we're going to plug in, but what we're looking for, what we're solving for is M. So how can I rearrange this to solve for M? What do I divide both sides by, Austin B? Austin B, what do I divide both sides of this equation by to solve for M?
Delta H.
Delta H, very good. Heat of vaporization. I'll call that heat of vaporization. All right, M equals Q over heat of vaporization. Now, Darius, you'd asked me about this. What is the Q for this problem?
24,000.
Very good. It's 24,000 joules over heat of vaporization, which is 2260 joules per gram. And what's the math there that I put into my calculator? Can you shut the door, please, Zach? I take 24,000 divided by 2260, and I get 10.6. We'll go ahead and round that to 11, and then my mass there is grams. So that's my final answer. All right, that's for quiz A. All right, now here they give me a specific heat. They give me heat, mass, temperature change. What am I looking for here? What am I trying to find? Heat. Which variable is heat? Which one of these 4 variables, Maggie, is heat? Nope, that's delta T. We're looking for Q, right? What is the mass on this one? Who had this quiz and knows how to do this one? Quiz A. Megan, what did you multiply? What's the C value here?
C is the 2.46.
Very good. Joules per gram degree Celsius, and then I'm going to multiply by my temperature change. Now, what's this, Sammy? What did y'all get for a temperature change? 35? 16 degrees Celsius will work there. Okay. So now we just multiply those 3 numbers together, and what did you girls get?
I thought it was a big number. I don't remember exactly.
All right, it's 7596. But I've got to round to 2 significant digits, so hopefully you got something like that. Okay? All right, something like that. Very good. Next. All right. I'm going to make this my answer key here. All right, next one, quiz B. Now, what if you had quiz A? Wouldn't it help to go over these quiz B problems? Because you might see something like this here in a few minutes. If you look at your practice mini test, it's fairly long, okay? So you're going to have several problems, and these are some of the problem types. So if I go over these, I think it'll help you on that practice test. All right, a piece of metal of unknown composition has a mass of 95.4 grams. It undergoes a temperature increase of 25 to 48 degrees Celsius, and the metal absorbs 849 joules of heat. What is the specific heat of this piece of metal? Lamar, what is the variable that represents specific heat? Close. What's the other one? Heat and specific heat are very similar. It's the other variable. C. Very good. All right, we're looking for C. So we're going to get rid of everything on both sides. Isolate C. Jasmine, what do I need to divide both sides of this equation by to get C isolated by itself?
Well, it all depends. C.
M and delta T. All right? Thank you. Now, that cancels this out, and we get C equals Q over M delta T. And here's the fun part. We just plug it in, don't we? Josh, Jocelyn, what's the Q? It's our joules. Joules. 849 joules, right here. We're just reading this, Jocelyn. What's our mass in this problem?
95.4.
95.4. Whoa, yeah, thank you. Good, you got it right, I got it wrong. I got the unit wrong there. Grams. And then delta T Z is what?
By itself. Oh,
No, it's not at all. It's together with all of us. How do I get it?
oh, you subtract?
Yeah, 48 minus 25. 48 is almost 50, right? Well, everybody knows that 50 minus 25 is 25, but this is 2 less. So, does that look right, Corbin? 23? Okay. So I just plug that in the calculator. Now, what do my units end up becoming on this one, Zach? The units aren't pretty, but what are they? Very good. It's joules divided by gram degrees Celsius, which I said isn't pretty, but that's actually what we want for specific heat, okay? It's the amount of energy, all right, that is required to raise the temperature of 1 gram by 1 degree Celsius of this metal, okay? Is this a reasonable specific heat? What's the largest specific heat we've ever seen for water? 4, right? So most of the metals are right here below 1. All right, so that's good. Next, how much heat is given off when 18.5 grams of water freezes at zero? There's no temperature change. So if we're at 0, Kat, what is the enthalpy value that we need? Fusion or vaporization? Very good, fusion. This is the one we want, okay? So I'm going to take the mass times the heat of fusion, multiply them together, and Corbin, this is the one that you had, right? All right, 6160 joules. There you go. Now, there's a bonus problem on that mini test practice where they give you moles. What would you have to do? They give you joules per mole. What would you have to do if you know joules per mole and they give you grams of that substance? What conversion would we need to make? Moles to gram. Who said that? Very good. All right, very good, Aubrey. Okay. All right, so that's how you do that. All right, excellent. Now, get out the practice mini test.